Imagine a robot standing in front of a cluttered desk. It doesn't calculate the torque of its motors or the friction coefficient of the wood. Instead, it pauses, closes its eyes, metaphorically, and visualizes the exact sequence of pixels where the desk is clean. This is DreamDojo, NVIDIA's latest breakthrough in generalizable robot world models. It represents a fundamental shift in how we teach machines to move, moving away from rigid math and towards something much more human, imagination. And the way they've built this is genuinely brilliant. By treating the world as a video to be predicted rather than a set of equations to be solved, they've unlocked a level of robot dexterity we've never seen before. To build a world model this smart, you need data, a lot of it. NVIDIA fed DreamDojo 44,000 hours of human video. That's equivalent to 5 years of continuous footage showing every possible way humans interact with objects. But it's not just about watching, it's about understanding. The model learns the subtle cues of how things bounce, slide, and break just by observing the pixels change over time. This isn't a pre-programmed set of rules, it's a learned intuition. And to process that much intuition, NVIDIA had to bring out the big guns. We're talking about 100,000 H100 GPU hours. That is a staggering amount of compute power dedicated entirely to teaching a model how the physical world looks when it functions correctly. This compute-heavy approach allows the model to simulate millions of what-if scenarios internally before the robot ever moves a single motor. It's training in a digital dojo where time moves at the speed of light. But here is the clever part. By training on human video instead of synthetic simulations, DreamDojo avoids the uncanny valley of physics where things look right but feel wrong. Traditionally, robotics relied on something called sim-to-real. You build a physics engine, simulate gravity, and hope it works in the real world. But the real world is messy. It has dust, weird lighting, and unpredictable surfaces. DreamDojo skips the physics engine entirely. It uses pixel-based outcome prediction. It asks, if I move my arm like this, what will the camera see next? If the predicted pixels show a successful task, the robot executes the movement. It's essentially visualizing its way to success. This shift is massive. It means robots can finally handle objects they've never seen before, in environments they've never visited. But how do you pack an entire world's worth of physics into a single model? The answer lies in the architecture. NVIDIA didn't just build one model, they built a family of them, ranging from small and fast to massive and incredibly smart. To understand how these visual guesses actually turn into real-world action, we need to look under the hood at the parameter counts, and trust me, the numbers are wild. NVIDIA developed 2 primary variants of the DreamDojo model, a 2 billion parameter version for fast, real-time edge processing, and a massive 14 billion parameter powerhouse. The 14B model is the brain that understands the deep nuances of the world. It's the one that knows that if you push a heavy box on carpet, it behaves differently than on tile. But having a big brain is only half the battle. You have to make sure that brain's visual guesses don't violate the laws of physics. This is the core challenge of pixel-based models, hallucinations. If the AI dreams that a cup can float in midair, the robot will try to make it happen, leading to a spectacular real-world fail. To fix this, NVIDIA uses a specific alignment process. They force the model to ground its visual predictions in the basic constants of our reality, things like gravity and solid body dynamics. They do this by comparing the model's dreams against a massive library of real-world physics data, essentially telling the AI, you can imagine anything as long as it follows these rules. The result is a model that can see the future of a physical interaction with incredible accuracy. It can predict how a soft object like a sponge will deform when squeezed or how a liquid will pour. And because it's trained on human video, it picks up on common sense physics that traditional simulators often miss, like the way a cord tangles or how a cloth folds. But here's the part that skeptics point out. Predicting pixels is computationally expensive. Running a 14B parameter model in real time on a robot's local hardware is a massive engineering hurdle. The true test of DreamDojo isn't in a simulation, it's in the real world. NVIDIA has been testing these models on a variety of humanoid and industrial robots, and the results are honestly wild. In one test, a robot was able to peel a banana, a task that is notoriously difficult because of the soft, unpredictable nature of the fruit. The robot visualized the peel separating and then just did it. This ability to handle deformable objects is a holy grail in robotics. It opens the door to robots that can cook, perform surgery, or help with elderly care.